Okay, so we'll be discussing this question today. In this question, it has been asked that there are basically n building, which will range from 0 to n minus 1, and there are, there are n building which will range from 0 to n minus 1, and there is an array which is request, which basically consists of a request made by the people living in the building. So let me tell you what let me tell what we'll have to do in this question. So I have been given n building children from 0 to n minus 1, and okay, what is happening in building range from 0 to n minus 1. Okay, let me open Google Doc as well, like Google Doc. Okay, so okay, so like there are n building, and which will basically range from 0 to n minus 1. Okay, and the people who is living in this building, basically all these building are occupied, fully occupied. So like the people will try to make the request. Basically they want to exchange the building, right? So suppose there are n building and every building has been occupied. So let's say the a request has been made from the people living in the building 0, and he want to go to the building 1. Then what could happen? From suppose there are x people at building 0, then it will reduce by 1. So the number of people at building x will become x minus 1, while number of people at building 1 will become x plus 1, right? Initially the number of people in each and every building was equal. Let's say there was x, and the people living from one people is living from building 1 0, and it will go to building 1. So like the number of people from 0 will reduce by 1, while number of people from 1 will increase by 1, right? So this is the scenario. So the problem is that we can't you can't do this thing. So like the request will be made, and at the end you have to tell what is the maximum number of requests that could be made, so that the number of people living a particular building will be equal to the number of people arriving to that particular building, right? So this is the total problem. Let's read the description of the problem. So like we have been given n building ranging from 0 to n minus 1, and every building have some employee. Okay, so like you are given the request array where request of I represent basically from I to 2i. The request of I will represent a particular people is living building I, and building from I, and it is going to building 2i. Okay. All building are fully occupied. Okay. So the list of the request is achievable only if for each building the net change in the employee transfer is 0. This means that the number of employee leaving is equal to the number of building moving in. For example, if n is equal to 3, the two employees are leaving building 0, and one is leaving building 1, one is leaving building 2. There should be two employee moving to building 0, one employee moving to building 1, and one employee moving to building 2. Yeah, this is what like we have discussed. The number of people that is living a particular building will be equal to number of people that should be arriving in that particular building, right? So this is the scenario, and at the end you have to return the maximum number of requests that you can make, satisfying all the above conditions. Okay, so like you can see this test case. Let's copy this test case. Mm, it is black here. I don't know. Okay, sorry. Why it is making black? I don't know. Okay, so like let me elaborate the discuss here only. So let's say the people. Let me copy it in Cali Draw as well. Okay, so this is the request that has been made, right? So what does this mean? Basically, there are five people, five building, and the people, one people will leave the building zero, and it will go to building one, right? So basically, here the number of people will reduce by one. So let me uh, represent it as a minus one, and here as a plus one. Okay, and in the second case the one people is leaving from one and is going to building zero, so here it will be overall the number of people at the building one will be balanced, so like it will become zero, right? And in this case also it will become zero because the one people has left the building zero and one people has arrived the building zero. Similarly, vice versa is also true for one. And then let's take the third case, test case. The people is leaving building zero and it is going to building one. Okay, so it will become plus one here, and again it will become minus one here, right? And the next test case is the people is leaving building one, a people is leaving building one, and it is going to a person is leaving building one and it is going to building two. So it will become what? It will become zero and it will become plus one, right? And then a person is leaving building two and and he is going to building zero. So it will become zero and it will become zero and it will become so yeah, it will become zero and it will also become zero. Another request is 3 to 4. So I mean from 3 to 4 a person will go. So like this is not achievable request because the number of person number of people will reduce by one, while here it will increase by one. So this is not a, satisfying request, right? While in this case, at the end, number of changes made at the zero, I mean the initially let's say it was x people, total x people, then at the end it is x number of changes here on this zero is getting that we are getting is zero in this case, and similarly for one and similarly for two. But in this case, a person is leaving building three and he is reaching to building four now. So in building three, the number of person will reduce by one, while in building four, the number of person will increase by one. So this is not a achievable request. So like in this way, we'll make a request. I think we have understood the problem. And at the end, we have to tell how much maximum request that you can make, right? And you can take this example as well. Here 0 to 0, I mean the person is residing in building 0 will not leave the building 0, and similarly the a person is living building 1 and he is going to building 2, and the person is living in building 2 will leave the building 2 and will go to the building 1. So like all three requests are satisfying, so because at the end number of changes made in each and every building is 0. So yeah, this is all about the question, and this is very simple question. As you can see, the constant here is 20. So like you can if the constant is 20, then one thing that should strike in your head is backtracking kind of thing, bit masking kind of things, and all, right? So like can we build the solution related to choices, like we can make the choices at each and every indexes. I mean at each and every indices there could be a two choices, either pick it or not pick it. So like can we think of all those kind of solution here, because 2 to the power n is acceptable in this case. It could be 2 to the power 20, which is basically equal to 2 to the power 10 into 2 to the power 10, that is 1024 into 1024, which is almost greater than 1 is 6, but it will be less than 1 is 7, and that is acceptable in this case, right? So like we can think of those kind of solution. So what we can do is that, so let's say let me copy one small test case here. Mm, okay, So now, okay, we can't do this. 0 0 1 to 0, n is equal to 3 in this case. Okay, so like n is equal to 3 in this case, n is equal to 3 in this case, and what are the request made? 0 to 0, and another request is mm, other request is 1 to 2 and 2 to 1, 1 to 2, 1 to 2, and 2 to 1. Okay, so these are the requests that has been made. Okay, so like can we build a solution related to pick or not pick that particular request kind of things? So what could happen if I will pick the first index? Okay, let's forget this. How will you build the solution for this problem? Okay, so let's say suppose if I'm let's say this is the request that is made by a person, and if I'm picking this, then what could happen? The number of person will reduce from the building one, and number of person will increase from the building two. So this is the thing that is happening, right? So can you think of degree like let's say we have built a array of size n, and add the, let's say we have built a array of size n, that is degree, and basically every value of degree of I will be 0, right? So what could happen is that a people is living building one, a person is living building one, and a person is going to building one, two. So like the number of person will reduce from the building one, while number of person will increase to building 2, right? So let's say initially the number of changes that were made is 0. So the degree for every I, the degree of I will be 0. So what could be the changes that we can make in degree array? That is, degree of 1 will be the person is living at the from the building 1, while the degree of 2 will be plus equal 1, while person is going to building 2. So this is the two case that will be happening, and at the end I will have to check for each and every I the value is 0 or not, because initially the value like we have to check that there should be no any changes in the initial number of people in each and every building, right? Because every building is congested and concurred, basically acquired by the people. So this thing we can do. Okay, so like can we so this is what I was telling. If a particular person is leaving the building, leaving a particular building, then at that moment I will just reduce the number of person at that particular building by -1, and if he is going to a particular building, then I will increase the number of person to that particular building by +1. Okay, so this is what I will be doing. And the next is just making a choices. So can I pick this building? Yeah, we can pick this building. I mean, we can make this request. And if we are making this request, then what could be the thing that we are going to do? Simply the degree of 0 plus equal 1, while degree of 0 minus equal 1. Or I will not pick this building. I will not pick this request. Sorry, I will not pick this request. So this is for picking. This is for picking. Like I have picked a request, picked a request, and then if I will not pick this request, then I simply I will move to the next request, and then there also we can make the these two choices. So either I will pick a particular request, or I will move to the next request, and again I will perform the same two choices, or I will not pick this request. So these are the choices that we can make at each and every indexes, right? So simply let's say this is the recursion call. Simply I will move to the f of I plus 1, and like here if I am choosing that particular request, then I will increase the count, right? And if I am not choosing, then uh, just maintain the degree array like what it was before, right? So like 0, uh, we have added the value, then we will do just -1, and then degree of 0 plus equal 1. And then I will move to the next index, the next request, and then CNT will be as it is. I will not increase the value of the CNT. And at the end, if I have picked for any recursion calls, if I have picked every request, then at the end, just I will be finding what could be the maximum request that I can get. Basically, that will be the best case. Best case could be, what could be the best case? If I have, if I have reached uh, last index of request array, right? Then at that moment, just I will simply I will do this thing. If this request dot size, then what I will do is that I will just iterate over the degree array. Less than degree dot size, um, and just I will check if degree of I not equal to 0, not equal to 0, I mean I have made every possible request, and at that moment, if I will find that any degree is not 0, then I will not do anything. Like that particular request is not achievable, that particular request is not available, right? That is what we have understood. Okay, like in this scaled row, it will disappear because everything is storing gas, so like it is temporary. Okay, so at that moment, just do nothing and return. While if it is satisfying, then what will I do? Okay, so like if it is satisfying, then I will simply take the max is equal to maximum of max is equal to maximum of this CNT, and then I will return. Simple. So this is the solution that I made by solving this problem. And talking about the complexity, let's talk about the time complexity. Time complexity of the problem will be simply, time complexity would be 2 to the power m, where m is number of requests, total number of requests that is possible. That is possible in worst case, right? One in worst case. While talking about the space complexity, then we are building this degree array, right? Degree array of length n, degree array of length n for just for degree array of, we are building degree of array n to just check if the degree the which person is living which building basically, and at the end just to check for every degree the value of value of every building is 0 or not. So like, and another space complexity is for recursion call, right? So how many recursion call will be made? The recursion call will be made to the power, there will be to the power m recursion call, right? While so the maximum depth of that recursion tree could be m. So overall time space complexity of this problem will be big of n plus m. So yeah, this is all about this problem, and let's see the solution. Okay, so like what I did is that if I'm at a particular index, so this is for picked, this is for picked a request, right? And this is for unpicked, like unpicked that request. Okay, and this is what best case that we have discussed. Simply check at the end, we have to check the degree of array, the degree array for every I, the value should be 0, otherwise if it is not 0, then that particular sequence of requests that we have built is not valid. So at that moment, just return. Otherwise, just take the maximum of whatever you have, whatever the count you have. Okay, and so like yeah, this is simple code.